Hello everyone and welcome back to CodeChef. Until now, we have been working with single tables in SQL. But in real databases, data is almost never stored in just one table. Instead, it is divided across multiple related tables. So, the big question is, how do we fetch data that is spread across different tables? The answer is joins. In this video, we will learn how to combine multiple tables in SQL using full outer join, self join and cross join. We will understand what each join does, how it works and when to use it with clear explanations and examples. So let's get started. Full outer join. A full outer join combines left join results and right join results. Basically, it returns all matched rows and all unmatched rows from both the tables. We can think of it as a union of both data sets with alignment where possible. Its syntax is select columns from table 1, full outer join table 2 on condition semicolon. So it is exactly the same syntax, the only difference is the name of the join. So here we are writing full outer join. Its use cases are first, data reconciliation, audit reports and data migration check. Now let us go to the CodeChef platform and see an example of how to use full outer join in SQL. So here is a task for us. Write a query to do the following. Full outer join the student and course tables using course ID to match the tables. Output the join tables. And here we have the expected output. So since we are joining both the tables with the help of the course ID, so first it will show records which have matching course ID. After that, it will show the records with unmatched course IDs with null values, as you can see in the last two rows. Coming to the query, select star from student, full outer join course on student.courseid is equal to course.courseid and semicolon. Now let's run this query. So as you can see here, it is exactly the same table. For matching course IDs, all the records are visible in the table. But for unmatched values, we have got null values for both right and left table. A self join is used when a table references itself and relationships exist within the same entity. SQL treats the same table as two different instances using aliases. We use self-join to combine a table to itself, and we do that when a relationship exists within the same entity. So the table references itself. And how do we do that? We create an alias for the table and then join those aliases which are actually referencing to the same table. Its use cases are organizational charts, category hierarchies, and parent-child relationships. Last but not the least, cross-join. A cross-join produces a Cartesian product, which means each row from table A pairs with every row in table B. Result size, rows in table A multiplied by rows in table B. Its syntax is select star from table 1, cross-join table 2, semicolon. So basically, when we want to join each and every row of two or more different tables, then we use cross join. And that is why its result size or the table that we get in the output, its size is total number of rows in the first table multiplied by total number of rows in the second table. The syntax is simple. Coming to the use cases, it is used to generate combinations, scheduling slots and creating test data. Now let's see an example of cross joins on the CodeChef platform. So here we have a task. Write a query to do the following. Cross join the table student and course and check out all possible courses a student can opt. Then output only two columns, the name of the student as student name and courses as course name. So first we have to apply cross join on two tables which are student and course, and then we can see what all possible courses a student can choose. And then in the output, we will show only 2 columns from that table, which are student name and course name. And here is the expected output. Let's have a look at the query. Select student name, course name from student, cross join course, semicolon. Now let's run the query. So we have fetched only 2 columns, student name and column name, from the table that we got after applying cross join on table student and table course. At this point, you have crossed one of the most important milestones in SQL. If you understand joins deeply, you are no longer writing beginner level queries. Then you are thinking like someone who can work with real production databases. Remember this: tables store data, joins create relationships, and relationships create insight. The more complex your queries become, the more joins you will use. Keep practicing these joins on the CodeChef platform, because practice is where real learning begins. Thank you so much for watching.